All right, let's dive into one of the most practical design patterns you'll ever use in Go, the builder. If you've ever found yourself struggling to create a really complex object, you're in the right place. We're going to break down how to build them the right way, nice and clean, step by step. Oh boy, we've all been there, right? You're trying to spin up a new Kubernetes deployment, or maybe piece together a complex database query. The options just keep piling on. Containers, volumes, labels, timeouts, credentials, and all of a sudden, your nice, simple struct has turned into an absolute monster. So how do you even begin to build it without pulling your hair out?
Well, you could try this thing, the dreaded telescoping constructor. It's just a single function with this ridiculously long list of parameters. I mean, look at that. It's impossible to read, it's a total nightmare to maintain, and you know you're going to mess up the order of the arguments at some point. This is a classic anti-pattern, and trust me, there is a much, much better way.
And look, this isn't some abstract ivory tower problem. We run into this all the time in the real world. Just think about building an HTTP request. You've got the method, all the headers, query parameters, the body. Or what about a gRPC server? You've got interceptors, credentials, keep-alive settings. You get the idea. These things have to be put together piece by piece, and that's exactly where it all gets so messy.
So how do we fix this? Well, this is where the builder pattern swoops in to save the day. The core idea is actually super simple, but it's incredibly powerful. It splits the process of building something, the steps you take, from the final thing you're actually building. This is amazing because it means you can use the exact same construction process to create totally different things, like, say, a car or a motorcycle. To really get this, let's use an analogy that I think makes it all click. Imagine an assembly line and a vehicle factory. This picture is going to be our guide through the whole pattern, so let's go ahead and meet the key players on our factory floor.
First up, we've got the director. This is our factory foreman. The foreman has his clipboard, and he knows the exact sequence of operations, no matter what. Step 1, install the chassis. Step 2, add the wheels. Step 3, put in the seats. Now here's the crucial part. The foreman has no idea if he's building a car or a motorbike. He doesn't care. He just follows the same stable checklist every single time.
Next, we have the builder. This is the actual assembly station, and this is where the specific work gets done. So the car assembly station hears the foreman yell, "Add wheels," and it knows that means installing 4 of them. But the motorbike station next to it hears the same command and knows it only needs to install 2. Each builder is a specialist that knows the nitty-gritty details for its own product.
And finally, what rolls off the end of the line? That's our product. It's the finished vehicle, the fully constructed complex object, our brand new car or motorbike. It's the final result of our director guiding our builder through that step-by-step process.
Okay, enough of the factory floor analogy. Let's see how this whole blueprint translates directly into Go code. We're about to build our foreman and our assembly stations and watch them work together. The first thing we need is a contract, a shared set of rules for all of our builders. In Go, that's usually an interface. It lays out the universal steps our director is going to call, like set wheels, set seats, and so on. Any builder that implements this interface can be plugged right into our assembly line. It's that simple.
Now you could use the builder by just calling each method on a separate line. And hey, it works, but it feels a little verbose, a little clunky, don't you think? There's a much more elegant way to do this.
And that's through something called method chaining. By making each set method return the builder itself, we can link all the calls together into this single, fluent statement. It almost reads like a sentence describing what you're building. This is a really clean and powerful technique, but this convenience, it comes with a pretty important trade-off.
And here's the catch. Because each method has to return the builder to allow for chaining, it can't also return an error. So what does that mean? It means you can't check for an error after each individual step. All of your error handling gets pushed to the very end, usually to a final build method. It's a classic design choice. You're trading immediate error checks for a much cleaner API.
So, let's get back to our foreman, the director. In the code, its construct method is where that stable, unchanging algorithm lives. Notice the order here. Seats first, then structure, then wheels. The director just calls these methods on whatever builder it was given, enforcing this exact sequence to make sure every single vehicle is built consistently.
Okay, so our factory is humming along, we're churning out cars, we're making motorbikes, everything is great. And then, of course, management shows up. They've got a new requirement, we need to build a bus. So, does this mean we have to shut down the whole factory and retool everything?
Absolutely not. And this, right here,
is the real magic of the builder pattern. It's a perfect example of a core software design principle called the open-closed principle. It means our system is open for extension. We can easily add a new bus builder, but it's closed for modification. We don't have to touch a single line of our existing working code. The director doesn't change, the car builder doesn't change. We just add new functionality without risking anything that's already there. It's beautiful.
Now, the classic director-builder pattern is fantastic, don't get me wrong. But in the world of modern Go, there's another approach that's often more idiomatic, especially when you're dealing with configurations. So let's take a look at the functional options pattern.
So, let's put these two head to head. The classic pattern is your best friend when you have very distinct types of products, a car, a bike, a bus, and you have to enforce a specific build order. Functional options, on the other hand, really shine when you have just one type of object, but with a ton of optional settings where the order doesn't matter. You'll see this second pattern everywhere in popular Go libraries like gRPC and Zap.
Okay, so you've got two powerful patterns in your toolbox now. How in the world do you choose the right one for your next project? Let's distill all of this down into a super clear decision guide. You're going to want to reach for the classic builder pattern when your construction process is stable and repeatable. If the order of the steps is absolutely critical and you're building a few very distinct types of an object, this pattern gives you that structure and safety you need.
On the other hand, you should probably go with functional options when you're dealing with a single object that just has a boatload of optional settings, and most of them have good defaults anyway. If you want an API that feels natural and familiar to other Go developers, and the order of configuration just doesn't matter, this is almost always the right call. So there you have it. We've laid out the entire blueprint, from the factory foreman all the way down to the individual assembly stations, and we've even looked at a more modern alternative. You now have the tools to go back and tackle that crazy 15-field struct with total confidence. So the only question left is, what complex object are you going to build first?